So with Algebra 2, we're going to continue on talking about the domain and range of a function, some more function stuff. And just so you are aware, the set of inputs, as a reminder of all x values. I know it says that result in an output, but it's basically just the domain is all x values. Leaving you live with the outputs. All outputs are all the y values. That's going to be called the range. Now, if anybody plans on taking math in college, there's a phrase called codomain, which is all possible y values. But for our purposes, we're only going to concentrate on the y values that are hit, so to speak. So in a problem like this, just starting with the x values, the inputs are the months. So the x values would be considered January, February, March, so on and so forth. And the outputs are the days of each month. So in this case, the number of days is a function of the month of the year. Assume this is restricting to non-leap years. So in roster form, which I guess I need to explain, that roster form we usually just put the brace up. So it kind of looks like an S with a backwards S. You probably can see it on your Chromebook. The set that represents the domain. So just to keep it simple, I'm just going to write Jan, Feb, Mar, so on. And sometimes with math people, you'll even see when there's clearly a pattern going on, you might see this is called an ellipsis. It just says it goes on with the same pattern all the way till you get to December. So again, they're going to ask you for roster notation for the set that represents the range. So because it's days of the month, we just want the total days. So February has 28. We definitely want to skip 29 because then it's no longer a function. Then February would have two outputs. That's why we're ignoring leap years of February having 29, but other ones like 30 and 31 also exist. If we ever have a test and you really don't know how many days are in a month, you can ask me. That's not the point of this class, but it's trying to get you to think outside the box and how you can think of not just numbers having a domain and a range, an input and an output. I think that kind of solidifies that idea. And so when we look at the next problem, notice that the function notation, instead of writing f of x, they wrote it as f of n, because remember, the inputs don't have to be x values. They could be t, they could be h. We saw that in a previous problem. It just happens that it's usually x values, so I do need to make that distinction. This is what's called a mapping diagram, where the domain is usually written first, and we just put a circle here. And what we do is we map. If we were to put 1 in for n, what would we get for the output or the range? Well, 2 times 1 is 2 plus 1 is 3. And sometimes we even draw arrows that connect them, like 1, 3 is an ordered pair. And then 3 doing f of n, 2 times 3 is 6 plus 1 would give me 7. And then 5 times 2 is 10 plus 1 is 11. And you might even see someone describe the range as in roster notation 3, 7, 11. Now it's very important that you do the braces that way, because we're going to talk in a bit about interval notation. So what I like about this problem is he's getting you to understand how to read domain and range by giving a graph. Now I've also seen the problem explained this way, where the author draws a box and fits all of the values inside of this box. So this might work for you, and I'm trying to do a yellow highlighter just to just to help you out. Because if I go back, let's just do orange, x values, since the x-axis is left and right, the lowest x value, the minimum x value, would be furthest to the left. So as I count, the furthest to the left is -3. I don't know exactly how I want to write it. Maybe subscript x could be that, and then the max of subscript x would be furthest to the right. 1, 2, 3, 4, 5, 6. If you're going to argue, my question would just be, well, is there any other points on here that are further to the left or further to the right? And I like this box because I've also had students say, well, this is the smallest y value. Maybe I'll put it out in red. That's the smallest y value. And I would say, well, are there smaller y values? And you might then say, oh, well, down here is a smaller y value at 1, 2, 3, 4, 5, -5. In that case, if that's the smallest, then yes, that's the minimum. And same thing goes with the max y. I've had students actually point out this one. They're like, well, this little turning point was the smallest, so this turning point would be the highest. And to that person, I would say, well, is there another point that's even higher than y equals 3? 1, 2, 3. And I hope you would identify this point over here at y equals 4. So the reason why that is helpful is there's what's called set builder notation. Let me at least introduce set builder notation, but I'm a bigger fan of what's called interval notation. In set builder notation, I'm going to do the domain first. It's read this way in math, is values for x satisfying, so they put a little line right there, that the values for x, -3 is the smallest x, is less than or equal to that, or less than or equal to 6. So I want you to at least be introduced to this, and I'm confident that you are probably pretty exposed to that statement, that -3 is less than x is less than 6. But I'm also going to point out what is interval notation, where if you want to, you just write the smallest number first. We always read interval notation left to right. And there's a distinction between being equal to or not equal to. And if you're equal to, you put a bracket with that number. So -3 is equal to an x value, and we also want to do equal to for 6. So let's say we wanted to, it's kind of off topic, but if we wanted to say -3 is less than x is less than or equal to 6, which we don't in this problem, but the way we would write it is -3 with a parenthesis and then 6 with a bracket. Which it gets very confusing if you have two that are not equal to, because then there's two parentheses. And again, it's confusing because then it looks like an ordered pair. So I'm just going to cross that off real quick because that's not the answer here, but that's an introduction to interval notation. So same thing goes for range. You want to write the brace, values for y, satisfying that the smallest y value is -5, less than or equal to y, is less than or equal to 4 was the highest y value. Or in interval notation, we would write bracket because it equals -5 to 4 with a bracket. So let that soak in. You can pause the video, you can go back and read through things. Yeah, so you can see we're dealing with interval notation on the very next problem. And we have the graph already. And what we have is we want to state the domain and range in interval notation. Well, notice that we have the endpoints are going infinitely to the left and to the right, and infinitely up. So the way that we do interval notation, well, let's even try to put a box around this, and we could go infinitely to the left and the right. So all of these domains are really bad except for option 3. That's the only answer that really works, because we do we never stop going to the left and we never stop going to the right. And by the way, that's your symbol for infinity if you've never seen that before. And you can confirm that it's correct, and I'll confirm with this pink color, because look at the lowest y value. It is -4. Is there a upper bound for the y values, and that because it's going infinitely up? That answer is no. So in interval notation, we are going infinitely up. And notice that we're writing this left to right, smallest number to the biggest number. This is the same thing, so I'll put a little equals here, that y is greater than or equal to -4. This top one, the domain saying -infinity to infinity, is the same thing as saying all, like x can be anything. X could be all reals. I think you've seen that before in Algebra 1. Let's see, I must be missing a symbol in here. Sometimes the symbol that I'll use is a double-barred R, which I'm not sure why it didn't show up on my notes here. So you will fill that in. So that means that we can be all real numbers. That's why we use R for real. In the next problem, we're going to talk about the calculator. And if you were to try to figure out f of 1 and f of 6 from looking at this table, remember this is when x is 1, what's the y value? So as you're looking at when x is 1, the y value is -1. And same thing with when x is 6, the y value is 6.5. And think about it for a second. You might even pause the video, and the table is created from this equation. Think about how you could have gotten those answers already. And while you're doing that, also think about why the calculator gives you an error at x equals 4. And those two things might be related. And what you could try and do is just plug in 4 in for both of those x's. And when you do that, I'm just going to draw an arrow right here because it's not quite equal, is 2 times 4 is 8 plus 1 is 9. You're dividing by 0. And dividing by 0 is undefined. We cannot divide by 0, so that gives us an error in the calculator. And then the last thing, are there any other values except for x equals 4 that are not in the domain? And that answer is simply no, that all other values work. Because the only limitation that we have right now is we cannot divide by 0. I'll write that down. We cannot divide by 0. And the very last question, it's just getting you to think about what would be in the domain of a problem like this. And think about what are some limitations on square root problems. Maybe you learned them in Algebra 1, maybe you didn't. And I'm about to give you the answer, is that we can only square root, so x plus 4, at least 0. So if I asked you to plug in 0 in for x, well, 0 plus 4 is a positive. Yeah, I can square root that. So that's not correct. Plug in 5. 5 plus 4 is 9. Yeah, the square root of 9 is 3. I can plug it into a calculator. Now be careful, because some people think about -3. Oh, that's a negative, so that must not work. But once you add 4 to it, you're back to a positive. We know the square root of 1. So that's not correct. We're looking for the values that are not in the domain, and that's anything. If you were to subtract 4 over, the domain would be any values at least bigger than -4. So that's why -8 does not work. -8 plus 4 is -4, and we cannot square root -4, which is why option 4 is incorrect. So as far as explaining your answer, I think that's good work right there. Interval notation, we would write that as -4 to infinity. And that's something we might just need to practice as we progress through this unit.